The Dynamic Learning Maps Alternate Assessment System is a new assessment designed to more validly measure what students with significant cognitive disabilities know and can do. This presentation is a follow-up to the module Counting and Cardinality and will provide a more in-depth look at forms of number for students with significant cognitive disabilities who will complete the alternate assessment. This training is one in a series of training videos that supports teachers of students with significant cognitive disabilities in their efforts to teach and assess. Sponsored by a grant from the U.S. Department of Education, Office of Special Education Programs, this training is part of the professional development efforts of the Dynamic Learning Maps Alternate Assessment Consortium. In the previous module, Counting and Cardinality, you were provided with an overview of the different aspects of number structures. In this module, we will look more closely at the various forms of number associated with counting. When children are learning to count, there are two major concepts to master: what to count and how to count. They sound like pretty easy skills to teach, but for all children, including children with significant cognitive disabilities, this is a major milestone, and the way the information is presented influences the student's understanding of number sense. Typically, teachers have taught number names to students with significant cognitive disabilities in isolation, what's referred to as rote or verbal counting. Teachers taught one-to-one correspondence by matching objects and created sets of items to be counted, placing them in rows or columns for the student. So the organizational system was imposed on the student. And although our data showed steady progress on each one of these individual skills, some of our students never seemed to put all of the pieces together. They struggled to figure out what to count and how to count, and they continue to not make the connection between the last number counted and how many are in the set. Furthermore, our typical instruction never helps students with significant cognitive disabilities learn the concept of hierarchical inclusion, which is the understanding that numbers are nested inside of each other and that the number grows by one with each count. For example, 17 is inside of 18. If I have 18 objects, I also have 17 objects, or 16, and so on. Or 18 is the same as 17 plus 1. And if you remove 1, the number goes back to 17. Part of the issue is that students with significant cognitive disabilities tend to compartmentalize their thinking and don't build the bridges between chunks of knowledge. Think about your students. How many of them can count 1, 2, 3, 4, 5, etc., but are unable to name the numbers in sequence when working on one-to-one correspondence? When learning occurs in decontextualized or disconnected segments, then the students learn isolated skills without being able to generalize the knowledge or apply the knowledge in novel situations. An alternative approach includes providing the student with a context and a purpose for instruction, using repetition with variety, modeling the use and forms of number, and utilizing explicit instruction. In other words, connecting the skills with the concepts. Number can take on a variety of forms. For students who are learning to count, regardless of their age, it is important that they experience 3 forms of number. The first and simplest form of number is concrete. It involves the use of concrete manipulatives that students are able to touch, feel, see, hear, or taste. When new math concepts or skills are introduced, start with the concrete materials such as chips, connecting cubes, base 10 blocks, beans and bean sticks, pattern blocks, and virtual manipulatives. For all students, including students who are unable to physically access manipulatives, there's a growing body of evidence which indicates that manipulatives, even virtual manipulatives, helps students gain a sense of number. Using a variety of concrete or virtual manipulatives supports repetition with variety that helps maintain the student's attention and motivation. Math concepts and skills can also be modeled at a pictorial or semi-concrete level. This involves drawing pictures that represent the concrete objects. Drawings such as tally marks, dots, circles, stamps, or computer-generated representations can all be used to help a student develop a deeper understanding of quantity. Again, students should be provided many opportunities to practice using a variety of pictorial models as they develop number sense. Finally, math concepts and skills can be modeled at a symbol or numeral level. Given appropriate instruction over time, students will learn to associate numerals and mathematical symbols with pictorial and concrete models of quantity. These forms of number are interrelated, and the goal of instruction should be to learn what to count and how to count. Remember that what to count includes recognizing that any collection of objects can be counted, and the order in which objects are counted is irrelevant. And how to count includes counting in a stable order, assigning word order in a one-to-one manner with items in a set, and knowing that the last word counted indicates how many are in the set and includes all the numbers that came previously. When planning units, be sure to think about how these forms of quantity might be integrated into various lessons. For example, to help students understand the connection between these three forms, teachers can model the pictorial and numeral quantities while the student is working with the concrete items. However it's accomplished, students should be exposed to these forms so they are not new experiences, but extensions of previous experience when they are working with each of the forms. When concrete, pictorial, and symbol forms are integrated in meaningful counting activities, they blend conceptual and procedural understanding in a structured way so that students learn the what and how of counting. Pause for Activity 1. There are broad goals that apply across grade levels regarding counting. They are: count consistently and accurately, use numbers to answer how many, determine one more or one less without counting, recognize groups up to 3 without counting, recognize numerals, write numerals, use numerals to record data. Notice that there are no number ranges associated with these goals. Each of these, along with specific ranges, are specified by grade in the DLM Essential Elements. Across grade levels, students are expected to be able to count increasingly larger quantities, first in increments of 1, but soon pairing the knowledge with counting by 2s, 5s, and 10s. In the early stages of learning to count, it's important to help students view quantities as values rather than labels. So much of their language learning involves naming and describing, but numbers are different. You can't see a number, it's a concept. For example, in learning language, children learn that these are apples. But we also tell children this is 3. This can be very confusing to students with significant cognitive disabilities. When teaching students to connect numeracy to objects, it's a good idea to start with familiar or meaningful objects. For example, counting body parts, familiar people, shoes, toys, and books, and then move towards increasingly novel manipulatives. By pairing known objects with numerals, we can have more confidence that students will successfully distinguish between the name of the known object and the quantity we are trying to get them to attend to. As you begin to pair numbers with objects, it makes it possible to count anything and everything. You can also start to provide experience with number lines and choose books for shared reading that involve numbers. It's also helpful to use 5 and 10 frames to compare numbers. Finally, you want to engage students in collecting and charting data as often as possible. There are a wealth of activities and materials for teaching counting that can be found on the internet. A great example is Counting Hands, a fun interactive way to help students see and create the forms of number. Counting hands can be used to represent numbers 0 through 10. Paired with number cubes, dot cards, numerals, or other concrete materials. It's also a great way to compare small numbers. For example, this hand shows 2. How many more fingers should we raise to make 3? Regardless of the activity, remember in your lesson to model the behaviors and the language you want students to use. Provide hints and cues, feedback and help when needed. And expect the students to use their mode of communication to talk about the numbers. For example, using numbers to count, telling how many in all, and for students using partner-assisted scanning, indicate, move it, or choose it. Directions for making counting hands can be found on the website provided at the bottom of the slide. Finally, some students with significant cognitive disabilities can be hard to motivate, but using the alternative approach to instruction, as discussed on slide 8, it may help you find activities and materials that provide the student with new ideas, new interests, and new motivation. The alternative approach provides the student with a context and purpose for instruction, uses repetition with variety, models the use and forms of number, and utilizes explicit instruction. Pause for Activity 2. Thank you for participating in the Forms of Number module. For further information, please go to www.dynamiclearningmaps.org.